At this sprawling lab at Google's Silicon Valley headquarters, these racks and racks of servers aren't running workloads for Google Cloud's millions of customers.
Here, for example, is the very first Trillium system that we built. This is a full Trillium system with 256 chips in it, 4 racks.
Or for YouTube, or the world's most dominant search engine.
And what is Trillium?
Trillium is our latest generation TPU. It'll be public later this year.
Instead, they're running tests on its very own microchips, tensor processing units, that help power it all.
Search and, of course, video, YouTube, ads, everything Google does has been powered in many ways by its own homegrown TPU.
Now, TPUs are used to train AI models like Google's own chatbot, Gemini, and in some big news, Apple's AI too.
Apple actually, we found out yesterday, they disclosed in a paper, they're using Google-made chips.
The world sort of has this fundamental belief that all AI, large language models, are being trained on NVIDIA. But Google took its own path here.
And yet, despite being the birthplace of some foundational concepts behind generative AI, many say Google's fallen behind in the AI race. But it was the first major cloud provider to do custom AI chips.
It was 10 years ago, almost to the day, where we decided that to meet the needs of our users in terms of a particular application, voice recognition at the time, we needed to design custom hardware.
In the years since, Amazon, Microsoft, and Meta have started making their own AI chips too.
Here we're turning on the chips and the boards for the first time, making sure they're working properly to specification, debugging any issues that might come up, that sort of thing.
And no media has been inside here before.
First time, yep.
We went to Google headquarters for an exclusive look inside the chip lab and sat down with its top executive to ask why and how Google's betting big on the expensive, complex business of custom chips. It all started in 2014, when a group at Google calculated that in order to launch upcoming voice recognition features, Google would need to double the number of computers in its data centers. Amin Vedat, now the head of custom cloud chips, started at Google 4 years before that.
A number of leads at the company asked the question, what would happen if Google users wanted to interact with Google via voice for just 30 seconds a day? And how much compute power would we need to support our users? We realized that we could build custom hardware, not general purpose hardware, but custom hardware, tensor processing units in this case, to support that much, much more efficiently. In fact, a factor of 100 more efficiently than it would have been otherwise.
What is a tensor processing unit, and did you guys coin that term?
We did. We coined the term tensor processing unit. We believe that it was certainly the first large-scale hardware accelerator for AI applications.
There's a whole gamut of qualification validation tests we do on power, thermals, functionality. You're really trying to make sure the design has enough margin so that it's going to operate well at volume, at scale.
Principal engineer Andy Swing, who ended up leaving Google since our visit, was there for the first launch.
There's actually 4 chips inside there. It's connected, actually 2 of those are connected to a host machine that has CPUs in it. And then all these colorful cables are actually linking together all of the Trillium chips to work as one large supercomputer.
Google data centers still rely heavily on chip giants like Intel and AMD for central processing units, CPUs, and NVIDIA for graphics processing units, GPUs. Google makes a different category of chips called ASICs, application-specific integrated circuits, which are more efficient because they're built for a single purpose. Google's best known for its AI-focused ASIC, the TPU, but it also makes ASICs to power YouTube called VCUs, video coding units. And just like Apple, Google also makes custom chips for its devices. The G4 powers the new fully AI-enabled Pixel 9, and the new A1 powers Pixel Buds Pro 2. But the TPU is what set Google apart, because when it launched in 2015, it was the first of its kind.
So the AI cloud era has completely reordered the way companies are seen. And this silicon differentiation, the TPU itself, may be one of the biggest reasons that Google went from the third cloud to being seen truly on parity, and in some eyes, maybe even ahead of the other 2 clouds for its AI prowess.
Amazon Web Services announced its first cloud AI chip, Inferentia, in 2018, 3 years after Google's came out. Microsoft's first custom AI chip, Maya, wasn't announced until the end of 2023.
In order to stay differentiated, to stay competitive, to stay ahead of the market, and to not become overly dependent on any supply chain partner or provider, they needed to do more, build more in-house.
According to Newman's team's research, Google TPUs dominate among custom cloud AI chips, with 58% of the market share, and Amazon comes in second at 21%.
They're more flexible, but they've been in tight supply.
The AI boom has sent NVIDIA's stock through the roof, catapulting the chipmaker to a $3 trillion market cap in June, surpassing Google's parent company Alphabet and jockeying with Apple and Microsoft for position as the world's most valuable public company.
Being candid, these specialty AI accelerators aren't nearly as flexible or as powerful as NVIDIA's platform, and that is what the market is also waiting to see, is can anyone play in that space?
Now that we know Apple's using Google's TPUs to train its AI, the real test will come as it rolls out those full AI capabilities on iPhones and Macs next year.
They were renting chips from Google for about $2 an hour, times gazillion chips, to train their AI models. So they didn't even need NVIDIA.
All the market pull is coming from NVIDIA, but longer term, people are just going to want to do AI things. And when they want to just do AI things, they may be just as happy to do it on a TPU or do it on another homegrown piece of AI dedicated silicon.
But developing alternatives to NVIDIA's hugely powerful and costly chips is no small feat.
It's expensive, you need a lot of scale. And so it's not something that everybody can do, but these hyperscalers, they've got the scale and the money and the resources to go down that path.
But the process is so complex and costly that even the Googles of the world can't do it alone. Since the very first TPU 10 years ago, Google's partnered with Broadcom, a chip developer that also helps Meta design its AI chips. Broadcom says it's spent more than $3 billion on R&D to make these partnerships happen.
AI chips, they're very complex. There's lots of things on there. So Google brings the compute. Broadcom does all the peripheral stuff. They do like the I/O and the SerDes and all of the different pieces that go around that compute. They also do the packaging.
Then the final design is sent off to be manufactured at a fabrication plant, or fab, primarily those owned by the world's largest chipmaker, Taiwan Semiconductor Manufacturing Company, which makes some 92% of the world's most advanced semiconductors.
Do you have any safeguards in place should the worst happen in the geopolitical sphere between China and Taiwan?
Yeah, it's an important question, and it's certainly something that we prepare for and we think about as well. But we're hopeful that actually it's not something that we're going to have to trigger.
I think the entire world is at the same risk. It's not unique to Google, it's not unique to Amazon, it's not unique to Apple, it's not unique to NVIDIA. If Taiwan is not given the appropriate support, if it deals with unexpected end-of-day circumstances, it is not only going to set back any one of these companies, it's going to set back the whole world.
That's why the White House is handing out $52 billion in CHIPS Act funding to companies building fabs in the U.S., with the biggest portions going to Intel, TSMC, and Samsung so far.
Intel and TSMC, they're putting a lot of their own money into this as well. I'm heartened to see that, but I mean, it's going to take a long time to duplicate. So let's hope that it doesn't need to be duplicated.
Risk aside, Google just made another big chip move, announcing its first general-purpose CPU, Axion, will be available by the end of the year.
Now we're able to bring in that last piece of the puzzle, the CPU. And so a lot of our internal services, whether it's BigQuery, whether it's Spanner, YouTube, advertising, and more, are running on Axion.
But Google is late to the CPU game. Amazon launched its processor Graviton in 2018. Alibaba launched its own server chip in 2021, and Microsoft announced its CPU in November.
Why didn't you do it sooner?
Our focus has been on where we can deliver the most value for our customers, and there it has been starting with the TPU, our video coding units, our networking. We really thought that the time was now, starting a couple of years ago. Again, these things are a number of years in the making, to really bring our expertise to bear on the ARM CPUs.
I don't fault Google for pacing out the launch of Axion in a more delayed fashion. This wasn't as differentiated. It's not as differentiated to me. It is more of a supply game. It's more of a margin and vertical integration game for the company, whereas the TPU was truly differentiated. 6 generations, 10 years of experience.
All these processors from non-chip makers, including Google's, are made possible by ARM chip architecture, a more customizable, power-efficient alternative that's been gaining traction over the traditional x86 model from Intel and AMD. Power efficiency is crucial because by 2027, AI servers are projected to use up as much power every year as a small country. With TPUs, the ability to customize greatly boosts power efficiency.
This is our 2nd generation optical circuit switch. So our large TPU supercomputers are actually optically interconnected. It allows us to dynamically link together collections of TPU chips to custom tailor the dimensions to the job that's running. This is developed all in-house by us.
Power is a huge thing now. And, you know, anything you can do to try to improve efficiency, lower costs, and save power, I think you're going to do.
Google's latest environmental report showed emissions rose nearly 50% from 2019 to 2023, partly due to data center growth for powering AI.
Without having the efficiency of these chips, the numbers could have wound up in a very different place. We remain committed to actually driving these numbers in terms of carbon emissions from our infrastructure 24/7, driving it towards zero.
Training and running AI also takes a massive amount of water to keep the servers cool so they can run 24/7. That's why with the third generation of TPU, Google started using direct-to-chip cooling, a new way to cool servers that uses far less water. And that's also being used by NVIDIA's latest Blackwell GPUs.
We have 4 chips, and these are our liquid cooling lines that come in. There's essentially a cold plate here that has little fins in it, and it picks up the heat from the chip, puts it into the water, and that comes back out.
Despite challenges from geopolitics to power and water, Google is committed not only to its generative AI tools, but to making its own chips to handle the massive compute required by the craze.
I've never seen anything like this, and no sign of it slowing down quite yet. I think it's fair to say that we really can't predict what's going to be coming as an industry in the next 5 years, and hardware is going to play a really important part there.